Hi all, this is Mr. Yeager. Today we're going to do a few force diagram problems. During this would be where you're given a particular problem where an object is being pushed with a particular amount of force over a surface. And we basically want to find all of the other forces acting on it. This could be force applied, this could be frictional force, normal force, weight, mass, acceleration, net force, and the coefficient of friction. So it depends on the problem. Obviously, some of these things will be given to us. So here we go. We're going to figure out based on the problem what we got to do. Okay. So let me get rid of all that. So we have this first problem. A 5 kilogram object has a 20 Newton force pulling it to the right. The coefficient of kinetic friction is 0.1. You can see no units with the coefficient of friction. The first thing to do with all of these problems is to draw the free body diagram. Now, all these problems we're about to do, we're basically on horizontal surfaces. We're not into any particular problems yet where the surface is not flat. All right? Let's write down what we know. This object, it's on a horizontal surface. Sometimes I write the mass inside of it just to give me an idea of what it is. So 5 kilograms is my mass. What forces would be acting on this box? Well, it's on Earth, so we got weight. Weight would be pointing straight down. What's pushing it back up against the weight? The surfaces, and that would be called the normal force. We have an applied force to the right, all right? And it says there is a coefficient of friction, which means that there must be a frictional force going to the left. So there's my free body diagram, okay? And so this helps me figure out what everything is opposed to, what everything is trying to push against, and this can help me figure out my answers. So I know what the mass is. Mass is 5 kilograms, okay? I know the applied force is 20 newtons, and I know the coefficient of friction is 0.1. So where do I go from this, okay? The thing about these problems is it just depends on what's given to you. What can you try to solve for? So there's actually a couple things you could try to solve for initially, but the main thing that you'd probably go to first is what is the weight? Okay, we can figure out the weight because weight is equal to mass times gravity. I have the mass, 5 times, I'm going to use 10, is equal to 50 newtons. So we now know the weight is 50 newtons. Okay, 50 newtons going down. I'm going to draw that on my free body diagram. I'll add 20 here as well. Okay. So what can I do next? Okay. Well, I mean, we can sit here and go, can I solve for the frictional force yet? I can't. Okay. Basically, I know the formula mu equals frictional force over normal, and I know the formula F net equals m times a, which will equal the two forces opposing each other, Fa and Ff, because the object is moving or accelerating to the right. This would be the direction of motion. Okay, the object is moving to the right. So this is where the net force comes from. This is something that's sometimes difficult to pick out. Why don't I pick out weight and normal? Well, because the object's not moving up or down. And since I know it's not moving up or down, there, I got another answer. If it's being pushed down 50 newtons, that means the surface must be pushing up 50 newtons. The normal and the weight are equal to each other when you're on a flat surface and there's no forces pushing up or down against it. Okay? So normal is equal to 50 newtons. So now, there you go, look at that. Now I can go to my coefficient of friction formula. I can do frictional force equals mu times n, and I know both of these. Mu would be 0.1, n would be 50, so this equals 5 newtons. So there you go. Now I know the frictional force. Okay? I know the frictional force, 5 newtons. From there, excuse me, from there, I can now go with the net force formula. The net force, I can figure out net force not by MA, but I can figure it out by FA minus F, the frictional force. And so that would be F net equals 20 minus 5, which equals 15 newtons. All right? And there's only one more thing to solve for in this problem. Only one last thing. Okay? And that would be the acceleration. I need to give myself space again here. So that would be 15 newtons equals the mass, make sure you use mass and not weight, 5 times a, and there you go, my acceleration for this object is 3 meters per second squared. Okay, So we're going to do a few more. So but this is the basic part of it. What do you have? Where can you try to go solve the problem? So next one will probably go a little faster. A 40 Newton box is accelerated to the right at 3 meters per second squared. The force applied is 20 newtons. First step, draw the free body diagram. Weight going down, normal going up, applied force to the right. Now, you can again see I'm saying to the right. It could always be to the left if it says push to the left. All right. And there's going to be frictional force. It doesn't say it there. I'm going to go and tell you there will be frictional force because otherwise we're not going to get we're going to see very quickly that net force doesn't equal the applied force. Okay, so there must be something slowing it down a little bit. So what am I trying to solve for? I'll write it all down. I want M, I want A, I want F net, I want mu, I want weight, normal, force applied, and the frictional force. Now, again, some of these will always be given to you. I mean, not always, but they'll give you certain numbers. I know the acceleration is 3 meters per second squared. I know the weight is 40 newtons. Now, pay attention here. Sometimes people miss this. It gives you the box is 40 newtons. That must be the weight, not the mass. And the force applied, 20 newtons. So this one's a little bit different, giving you a different starting point. We got to feel comfortable going from being able to figure out these problems from any direction. What can I solve with this? Well, if I know the weight, I know the mass. So all I'm going to do is basically mass will be the weight divided by 10. Weight over gravity, 4 kilograms. 4 kilograms. So now that I know the mass, I have M and A. That's what net force is equal to. Equals M times A. That is 12 newtons. So this is how I knew that the applied force was not going to be, that I knew there was going to be friction because the applied is not equal to net. All right. What I can see here is this also equals applied force minus the frictional force. So there must be something subtracting out from the applied force. And I can see pretty clearly if it's 12 equals 20 minus FF, it must be 8 newtons. So FF is 8. Okay. Let me give myself a little room here. Okay. So what else can I solve for now? Well, I could have done this at the beginning. I don't know why I did it. The weight and normal must be equal. Okay? Weight equals the normal on any flat surface. Again, keep this in mind what I'm saying, as long as there's nothing pushing it down or lifting it up. Okay? So the weight and normal are equal, 40 newtons. We can basically use that as a rule for most of this unit. And that leaves me with just the coefficient of friction. Frictional force over normal. Frictional force is 8 divided by 40 equals 0.2. And 1/5 or 0.2, no units. Good. Next problem. You push an object at a constant speed over a surface with a frictional force of 30 newtons. The object is 10 kilograms. So once again, free body diagram. Weight, normal, applied, and frictional force. Now, again, it doesn't say which direction, but we're going to just leave it at this. Okay? I want to figure out the mass, the acceleration, the net force, the coefficient of friction, the weight, the normal, the applied, and the frictional force. All right, what do they give us in the problem? Mass is 10 kilograms. Frictional force is 30. That's it. So where do I go with this? This will cause some confusion. We could sit there and go, well, I can find the weight. Weight will be 100, 10 times 10, mass times gravity. I'll write that over here to make sure we're clear with that. I know then the normal force will be 100 because it's on a flat surface. But now I'm stuck. What do I do? They don't give me anything about, I can solve, wait, there's one more thing. I can solve for frictional force, okay? Coefficient of friction. This would be 30 over 100. So that's 0.3. But now I'm stuck because net force will equal m times a, which will equal Fa minus Ff. I have m, I have Ff, but I'm missing two middle variables, a and Fa. So what do I do with this? This is something that comes out of the reading. You've got to catch these words. Very, very important words. Constant speed. If it's moving at a constant speed, that means, according to Newton's first law, we're at equilibrium, which means there is no net force. There's zero net force. If there's zero net force, constant speed, that means there's zero acceleration. And what does that mean about the applied and frictional force? They are at equilibrium. They must be equal. So the applied force is 30 newtons. This is something that actually I did it the long way. When I see that constant speed, I'm going Fa is equal to Ff, 0 and 0. I put those in right away. It makes the problem go a lot faster. So the nice thing here is all the forces should balance out. So one last problem. An 8 kilogram object is pushed with a 30 Newton force, I guess we're saying, pushed with 30 newtons over a frictionless surface. Ooh, frictionless. So now my free body diagram would only include three forces: normal, weight, and applied. And therefore, I can already tell you frictional force is 0. I probably wouldn't ask about that. And the coefficient of friction must be 0. So I just need to solve for everything else. Net force, M, A, weight, normal, F applied. And I already know the F applied is 30 newtons. And the mass is 8 kilograms. All right, is 8 kilograms. So, what do I do with this? Well, I can solve for weight again. That would be 80 newtons, 8 times 10, mass times 10 gravity. Normal is 80 newtons, and all I'm left with is net and A. So again, in this problem, net force still equals ma, but what forces, what's causing it to accelerate? And that would only be Fa. So therefore, net force equals Fa, and so therefore the net force is 30 newtons. 30 divided by 8, what does that give me? It gives me 3.75 meters per second squared. Okay? So, that's how you approach some of these problems. What we're looking at, again, try to remember this. 1, draw out your free body diagram. Okay? Remember that weight equals mass times gravity. Vice versa. Maybe you're given weight, go back and solve for mass. 3, net force is equal to mass times acceleration, which equals the sum of the forces that create the acceleration. In most problems we're doing, it's going to be left and right. 4, coefficient of friction is frictional force over normal. Okay. 5, I know a lot of things to remember. Weight will equal the normal when it's a horizontal surface, when it's a flat surface. And again, you're not pushing down or up on the object. All right. And then one thing as a star, because it's not every problem, pay attention to the words constant speed, constant velocity. All right. If they are written, this problem has become a lot easier. There are zeros, acceleration is 0, net force is 0, and then all the forces should balance out. That's how you go after these problems, and I hope you do very well with them. Good luck.